Okay, so previously we talked about arithmetic sequences. What we want to do today is talk about geometric sequences. And so for our geometric sequences, we first want to learn how to identify when we have a geometric sequence. We want to learn how to find what's known as a common ratio for a geometric sequence. We want to be able to write a recursive and explicit formula for a geometric sequence, just like we were able to write one for an arithmetic sequence. It's just a different formula. And then we want to be able to find the nth term for a geometric sequence. So let's start by figuring out if something is geometric and then how to find that common ratio. So like we said before, sequences are when we're getting from one number to the next by some rule. So when we did arithmetic sequences, we might have something where we added 3 to get to the next number. And so we did a sequence like this when we did arithmetic sequences because we could say 4 minus 1 was 3, so that meant we were adding 3. 7 minus 4 was 3, so we were adding 3 again. And 10 minus 7 was 3, so we were adding 3 again. And that was that arithmetic sequence so that we could see that the common difference was 3 because that's what we were finding with arithmetic sequences. Well, a geometric sequence is one where we are not adding or subtracting to get to the next number, but we are instead multiplying to get to the next number. Or sometimes it looks like division, which is actually still multiplication. So for instance, we could have something like 1, 3, 9, 27. And so when I look at that sequence, what I can see is that to get from 1 to 3, I can multiply by 3. To get from 3 to 9, I can multiply by 3 again. To get from 9 to 27, I can multiply by 3 again. Multiplying to get to the next term is what is known as a geometric sequence. And that number that we multiply by to get to the next term is what is known as our common ratio. We'll call that R. So our common ratio for this geometric sequence would be 3. So let's look at some other sequences and let's determine if they're geometric. So let's say that we have this group of sequences. And I'll look at 1, 6, 36, and 216. I want to know, is it geometric? And if it is, can I find the common ratio? Well, remember when we were looking to determine if something was arithmetic, we were subtracting the second term minus the first term. Well, to decide if something is geometric, what we will do is we will take the second term, which in this case is 6, and divide by the first term, which is 1, and we get 6. And so what that means is that they would have multiplied, if we're trying to decide geometric, they would have multiplied by 6 to get to that term. And so we want to see, does it apply to all the terms in that sequence? So I can take the third term, 36, and divide by the previous term, which is 6. So we're taking a term and dividing by the term before it. And if we get the same thing every time, then we know we've created a geometric sequence. Okay, so then to get from 6 to 36, they multiplied by 6 again. So it's looking geometric. I'm going to attempt the last piece and make sure it just follows through. 216 divided by the term right before it was 36 is also 6. So because they have multiplied by 6 all the way through, then our answer is yes, this is a geometric sequence. And our common ratio, which we are calling R, so common ratio is going to be R, is 6 in this case. All right, so let's look at the next one. So if I want to look at example B, where I've got -4, -8, -16, and -32. And I need to determine if it's a geometric sequence. So I'm going to start with the second term, and I'm going to say -8 divided by the term before it, which is -4. And I get 2. And so what that means is that when they went from -4 to 8, they multiplied by 2. And so I'm going to go to the next piece. I'm going to take negative 16, and I'm going to see if it follows through. And sometimes once you know, you can just say, is negative 8 times 2 going to give me that? Is negative 16 times 2 going to give me that? And that's fine. But if you don't know, I'm showing you what to do if you don't know in the calculator. So we can take the third term and divide by the term before it. And hopefully we still get 2. And we did. We got 2. And so then I take the fourth term, negative 32, divided by the term before it, which is negative 16. And we get 2 again. So that means all of those had multiplied by 2 to get to the next term, which means that, yes, this is a geometric sequence, and our common ratio is 2. All right, let's look at example C down here. So when I look at example C, remember I want to start with the second term. So I'm going to do 20 divided by negative 100 because I want to use the term right before it. And I get negative 0.2. Now, if you don't like the decimal, which decimals are fine as long as we don't have to round them, but if you don't like the decimal, remember you can hit math, enter, and you can use the fraction. So you can either say this is negative 0.2 or negative 1/5. So I'm going to say that we have multiplied by negative 0.2 or negative 1/5, however you want to say that. And so now I'm going to test the next one. I'm going to go to the third term, and I'm going to say negative 4 divided by the term before it. Well, the term before it was 20. I get negative 0.2 again, which if I don't like, remember I can hit math, enter, and I get negative 1/5. So I multiplied by the same thing. And so I'm going to try this last one. The last term that I have is 4/5. So I'm going to do my fraction 4/5. I'm just going to type 4 divided by 5. Okay? And then I'm going to divide by my negative 4. And I will say, you can go get your fraction thing. Remember, on your calculator, you can hit alpha and x. I have to hit alpha y equals to get to mine. But you can hit alpha x and get the fraction. And you could type in 4/5 that way as well. And then divided by negative 4. And I, again, get the same thing. So because every time I divided a term by the term right before it, I got the same thing, that means, yes, this is a geometric sequence, and my common ratio is, whichever way you wanted to write it, decimal or fraction. I'm going to write the fraction negative 1/5. But you could use the decimal negative 0.2. All right, let's look at our last one. So as I look at it, starting with the second term, I'm going to do 4 divided by 8. All right, so I have 0.5, which you could change to a fraction if you want to. I'm going to leave it as a decimal this time. So I know that to get from here to here, they have multiplied by 0.5. So times 0.5. I'm going to put a little x this time for my times sign since I have a decimal. And then I'm going to go 0 divided by 4, because third term divided by the term before it. Well, I didn't get 0.5 this time. To get from here to here, they had to multiply by 0. Well, that means they're not multiplying by the same thing every time, which means this is not geometric, which means it has no common ratio. Now, if I look at this, I think this actually may be arithmetic, because if I did 4 minus 8, I got negative 4. And then when I do 0 minus 4, I got negative 4. And when I did negative 4 minus 0, I also got negative 4. This is instead an arithmetic sequence, like the ones that we talked about in the previous lesson. And so that would be arithmetic, which they didn't ask us. And the common difference would be that they have subtracted 4 each time. So when we do this on practice, or we do this on a quiz or a test, we're going to be looking at lots of them and deciding, is it geometric or is it arithmetic? Okay? So remember, if we are finding geometric, we are dividing a term by the term before it, and it has to work all the way through the sequence. If it's arithmetic, we are subtracting a term by the term before it, and it has to work throughout the sequence. If it doesn't work throughout, it may not be arithmetic or geometric.